Hello, and welcome to the 9th lesson of Big Data and Hadoop Administrator course, offered by Simplilearn. This lesson covers the overview of Hadoop clients, provides an introduction to Hue, how to install and configure it. After completing this lesson, you will be able to explain the concepts of Hadoop client, edge nodes, and gateway nodes. Install and configure Hadoop clients. Explain how Hue works. Install and configure Hue. Describe how authentication and authorization is managed in Hue. In the first topic of the lesson, you will learn about Hadoop client, edge nodes, and gateway nodes. There are three main categories of machine roles in Hadoop deployment. These include client machines, master nodes, and slave nodes. The master node runs master daemon, which manages two important functional parts that make up Hadoop: storing data in HDFS and using MapReduce or YARN to run parallel computations on that data. Slave nodes refer to the majority of machines that do all the storing and running of computations. Client machines, or client nodes, have Hadoop or packages of Hadoop components installed with all the cluster settings, without any master or slave daemons. The role of Hadoop clients is to regulate the data access from the Hadoop cluster. These machines are used to run client programs or APIs, which load data into the cluster and to submit jobs. The client node then retrieves information on data and job outputs when the job is complete. The client's interaction with the master node is inevitable for any kind of data read, write, or processing. It is important to consider that HDFS clients perform file system metadata operations through a single server known as the name node, and send and retrieve file system data by communicating with a pool of data nodes. Data is replicated on multiple data nodes, so the loss of a single data node should never be fatal to the cluster or cause data loss. The image on the screen shows a dev cluster setup, although a same kind of setup could be used for production, disaster recovery, test, or UAT cluster. Now let's look at how the interaction between a client and a cluster takes place. To understand the process of interaction, you need to know how the communication takes place, how the write is done from the client, and how the client ensures data integrity. On the next screens, you will learn about each of these in more detail. Let's start by understanding how a client and cluster communicates. All HDFS communication protocols are layered on top of the TCP/IP protocol. Therefore, the client establishes a connection to a configurable TCP port on name node. Data node communication with name node is done using the data node protocol. A remote procedure call, or RPC abstraction, wraps both the client protocol and the data node protocol. Name node never initiates any RPCs and only responds to RPC requests issued by data nodes or clients. Now let's see how the client writes the data. The Hadoop cluster is useful only when it has data. The client machines load the data into the cluster to achieve parallelism of large amounts of data. To achieve this, you would need as many machines as possible working on the data together. A request from client to create or write a file on HDFS goes through a caching mechanism before reaching name node directly. Data from file to be written is cached in temporary local file on HDFS client. Once the data accumulated is equivalent to the size of a block on HDFS, name node is contacted by the client. The file name is inserted into the file system hierarchy, and a block is allocated for it. Name node responds to client request by providing details such as destination of data block and its identity. Finally, block of data is flushed from temporary file to the specified data node by the client. If and when the file is closed, the remaining data from temporary file is transferred to the data nodes. Client also notifies name node about the closure of file and NameNode commits the file creation operation into the persistent storage layer, which is HDFS. The HDFS client software implements checksum, checking on the contents of HDFS files. When a client creates an HDFS file, it computes a checksum of each block of the file and stores these checksums in a separate hidden file in the same HDFS namespace. When a client retrieves file contents, it verifies that the data it received from each data node matches the checksum stored in the associated checksum file. If not, then the client can opt to retrieve that block from another data node that has a replica of that block. Now that you've seen how the client interacts with the cluster, take a look at how clients are configured and deployed. To allow clients to use HBase, HDFS, Hive, MapReduce, or Yarn services, Cloudera Manager creates configuration file zip archives, which contain service properties. These archives are also known as client configuration files. Client configuration files are auto-generated and auto-deployed based on services and roles in the cluster. For each host that has a service role instance installed, or for each host that is configured as a gateway node, any configuration changes made will result in stale client configurations and may demand redeployment. You will see how this happens on the next screen. For each host that has a service role instance installed, and for each host that is configured as a gateway node for that service, the deploy function downloads the configuration zip file, unzips it into the appropriate configuration directory, and uses the Linux alternatives mechanism to set a given configurable priority level. If roles for multiple services are running on the same host, for example, a data node role and a node manager role on the same host, then the client configurations for both roles are deployed on that host, with the alternatives priority determining which configuration takes precedence. To download the client configuration files, log into Admin Console and click the Services tab. From the Home button, select the status. Click the Client Configuration URLs button that shows links to configuration files based on services. Save the link and download the configuration files. To download an individual client configuration zip file, click the Services tab in the Admin Console. Proceed to select the service instance whose configuration you want to download. Then, from the Actions menu, select Download Client Configuration. This downloads the configuration files for the selected service. Apart from client nodes, there are other nodes, such as edge nodes, also known as gateway nodes. These nodes are the interface between the Hadoop cluster and an external network. Edge nodes are mostly used to run client applications and cluster administration tools. They are also used as staging areas for intermittent data when data is being transferred to Hadoop cluster. The image here shows some of the processes that can be run on edge nodes. The image on the right shows how it looks in a production environment. There are some considerations for edge nodes, although specifics always depend on business and technical requirements. It is recommended that apart from edge nodes, no other nodes are used to deploy and run administration tools. Running administration tools on master or slave nodes may give rise to a conflict for resources with critical daemons. You should avoid placing data import-export service like Scoop on master and slave nodes, as the high data transfer volumes may lead to reduced ability of Hadoop services to communicate with each other. High latency may, in turn, cause the nodes to get detached from the cluster. Edge nodes use carrier-class hardware. Edge nodes oriented to data ingestion should be equipped with optimum storage space. The processor configuration should be the same as, or a little more than, that of slave nodes. 48 GB of RAM would be sufficient. Edge nodes should be multi-homed, that is, connected to multiple networks, into private subnet of Hadoop cluster. 2 pairs of bonded 1 GBE network connections are recommended. One to connect to Hadoop cluster, and the other for external networks. To successfully handle high inbound and outbound data transfer rates, edge nodes should have multiple pairs of bonded 10 GBE network connectors. In this topic, you will view a demonstration on how to install, configure, refresh, and work with clients. Deploying client configurations and looking into configurations. In this demo, you will learn how to add a service to your cluster. First, click Cluster and choose your cluster from the list. Click Action tab and click Add Service, which will show you different options for the services. From the listed options, add Scoop 1 client and Scoop 2 service to your cluster. Select Scoop 2 and click Continue, which will set up Scoop 2 service to the cluster. Next, for the desired location to place the server, the service should be ideally placed on a machine which is not loaded much. Click Continue, and Scoop as a service will be added to your cluster. You can edit the changes in Review Changes tab. As you can see, Derby is the default database. If you need to store Scoop anywhere other than in Metastore, you can use a different database. After the review is done, click Continue. This will create the relevant directories on the HDFS for the Scoop 2 service, and it will start the Scoop service. Once the service is added to your cluster, you need to restart the service by choosing the Restart tab from the drop-down options for the service, and it will be part of your cluster without any problems. Now you will see how to add Scoop 1 client configuration service to your cluster in the following steps. First, choose your cluster. Then, from the Actions tab, click on Add Service. Next, from the Service options, select the Scoop-related client. The Scoop 1 client takes care of the configurations and connector management. Click Continue. In the Customize Role Assignments for Scoop 1 client, you can choose the machine in which you want to set up the gateway node. Click OK, and then click Continue. When it starts deploying client configuration, you can see the details of different client configurations. Once the client configurations are deployed, click Continue. Now, the new service has been installed and configured to the cluster. Click Finish to add your new service to the cluster. At any point of time, if you make changes to the configurations, you have to restart your services and fix the stale configurations. The stale configurations show what properties have been changed from before. In the next demo, you will learn how to add Hue as a service and how to set up Hue. In this demo, you have learned how to add a service to your cluster. In this topic, you will be introduced to the concept of Hadoop User Experience, or Hue. Hue, also called as Hadoop's User Experience, is a lightweight web server which consists of a web interface that allows users to interact with Hadoop, its components, and its storage layer from a browser. Hue can be set up and integrated with any Hadoop distribution and can be installed on any node of the cluster. It provides a suite of applications that allow interaction with Hadoop and underlying components with ease. The web interface allows users to work with Hadoop, operate and develop applications, and does not mandate knowledge of underlying file system and related utilities or commands. So why do we need a new interface when we already have Daemon's web interface, such as NameNode UI and Resource Manager UI? That is because these UIs are not capable of doing it all. They only allow users to browse information about cluster-specific or daemon-specific information. Making changes at cluster level, service level, or role levels is not allowed, and neither is working with data on the cluster. Hue, although a web interface, is an application in the background that allows users to interact with a Hadoop cluster from a web browser and requires no client installation. Hue has a set of applications that let you ingest data, browse HDFS and jobs, run Hive and Impala queries, and, in turn, submit MapReduce jobs, run pig scripts to work on and transform data, manage Hive Metastore, HBase, Scoop, Zookeeper, look into configurations, manage permission on HDFS, and work with workflows. In other words, Hue is one interface that does it all. The diagram shows Hue Server and its suite of applications that interact with the underlying services and components. You can also see where the Hue server is placed and its interaction with a cluster that has various services installed. How does Hue do it? Hue consists of a web service that runs on one of the nodes of a cluster. This node may be called the Hue server. Hue server is a container web application that sits in between the CDH installation, or any Hadoop distribution, and the browser. This hosts various web applications and communicates with the CDH services. Hue UI allows users to use various applications through a web interface. Hue applications internally interact with services configured to run on cluster. Hue Server makes communication easier. Hue Server uses a database to manage sessions, authentication, and Hue application data. Hue applications may run Hue-specific daemons. Hue applications communicate with these daemons either by using Thrift service or by exchanging the state through database. In this topic, you will learn about the various Hue application interfaces, such as Beeswax, Impala Query UI, Relational Database Management System or RDBMS UI, Pig Editor, Job Designer, Job Browser, Metastore Tables, HBase, Scoop Transfer, Zookeeper, and File Browser. Let's begin with the Beeswax application. This application enables you to perform queries on Apache Hive, which is a data warehousing system designed to work with Hadoop. Hive allows primitive and collection data types to impose structure on data and process the data using queries. The web editor on top of Beeswax Hive UI makes working with Hive easier. The later versions of Hue use Hive Server 2 instead of Beeswax. The web editor allows integration with user-defined functions, multiple query execution, download, save, execute, and reuse queries, navigation through metadata, query submission and checking output later, and query auto-completion and analysis of data. The Impala Query Application UI enables you to perform queries on Apache Hadoop data stored in HDFS or HBase data stored in HDFS. Impala provides fast, interactive SQL queries on HDFS data. It uses the same metadata and syntax as Apache Hive, Open Database Connectivity or ODBC driver, and user interface, making it a unified and easy platform for real-time and batch operations. Most of the Hive queries are compatible with Impala, and using Impala through Hue makes it easier to work on queries and therefore on the data that is stored in HDFS. The Metastore app, under Browsers, helps browsing tables with ease as it uses the same Metastore as Hive. The web editor has the same functions as the web editor of Hive. RDBMS UI is a new application that enables viewing data in other RDBMs, such as MySQL, PostgreSQL, Oracle, SQLite, and so on. The Pig Editor application allows you to define and run Pig scripts that may be used to extract or transform data and view the status of jobs if the query run has triggered a MapReduce job. The Job Designer application allows users to create and launch jobs on Hadoop cluster. Jobs can be enabled to accept variables when jobs are being run. Job Designer supports the actions supported by Oozie, MapReduce, Streaming, Java, Pig, Hive, Scoop, Shell, SSH, distcp, or distributed copy, FS, and email. The Job Browser application allows users to examine the jobs running on Hadoop cluster. Job Browser presents the jobs and the tasks in layers. The statement below shows how we look into jobs and related information. List of jobs, jobs tasks, tasks attempt and task priorities, start, end, output size, and so on, and job logs. Now let's learn about data browsers. The Table Browser application allows users to browse and work with Hive tables. Creating tables, browsing data, and loading data in tables is made easier through this application. It is not required to type or run queries. The HBase UI application allows users to work with HBase and unstructured, column-oriented HBase data on HDFS. Bulk data upload, Smart View to view the table, and other features make this UI a useful interface to interact with HBase instead of using HBase shell from terminals. Scoop UI enables users to transfer, that is, import and export data between structured and unstructured data sources using Scoop. Scoop is a batch migration tool extensively used for transferring data from relational databases to Hadoop HDFS. This application allows data import in various formats from various structured data sources and direct ingestion of data in other components of Hadoop ecosystem, such as Hive, HBase, Accumulo, and so on. The Zookeeper browser application helps in listing the Zookeeper cluster statistics and clients. Finally, let's look at the File Browser application. This application is very useful, as it allows multiple users to browse data, such as files and directories, in HDFS. Apart from browsing, it enables users to download, rename, move, copy, change ownership and permissions, sort data by attributes, view contents of files, and upload data using simple drag-and-drop operations through simple clicks. Using this GUI avoids logging into gateway hosts, terminals, and clients on edge nodes for these operations. Here is a picture that shows what the file browser looks like when the highlighted icon is clicked. Other set of applications, such as Oozie Editor and Dashboard under the Workflows tab, Solar Search under Search, Security Management under Security, Administration next to Job Browser, help users to handle other aspects of Hadoop cluster. Let's look at how they do this. In the Oozie Editor and Dashboard, to define the Oozie workflow, coordinate and bundle applications, run the workflow, and view the status of jobs. Use Solar Search to perform keyword searches across Hadoop data using a wizard that lets you style the result snippets, specify facets to group the results, sort the results, and highlight result fields. Security Management is used to handle security and privileges for Hive tables, Solar collections, and file access control lists, or ACLs. Administration is used to grant access to users to work in Hue and on HDFS. Adding Hue as a service and setting up Hue. In this demo, you will learn how to add Hue as a service and setting up Hue. When you are in Cluster 1, click Actions tab and then click Add Service. In Add Service in Cluster 1, choose Hue, which is a graphical user interface to work with Cloudera's distribution. Click Continue. Select the set of dependencies for the new Hue by choosing the second option of HDFS. Click Continue. Choose where you would like to place your Hue server from the given options of machines connected. Click OK. Click Continue. In the database setup, by default, Use Embedded Database will be shown. Click Test Connection. This will either test the connection or skip it. Click Continue. After this, we will set up Hue-related database for the Hue service. Now, once we start the Hue service, we can use the GUI interface to work with the cluster and use various applications within the Hue application without logging into the terminal. Now, click Continue. So, the Hue service has been installed and configured to the cluster. Click Finish. Now you will learn how to set up the Hue service in the next few steps. Click Hue from the cluster 1. Click Hue Web UI. Now this will take you to the web interface. You will have to log in for the first time with the username and password. Click Create Account by providing the credentials, and you will get your Hue admin rights. Now let us look at some of the examples which you can download. When you click Download Examples, it shows an error message as the username already exists. Now you will see how to download the examples, which will help you work with a different editor in the following steps. Click Administration, and then click Manage Users. You will see that there is only one single user, which is Hue. And if you try to delete that user by clicking Delete, you will not be allowed, as Hue is the only user. Click Go Back and click Add User. Provide the username and password. Also uncheck Create Home Directory, as the user directory might already exist, and click Next. Provide the name and other details and click Next. Make this user as superuser by clicking on Superuser Status, and then click Next. Once you create a user, click Sign Out to sign out from Hue. Log in with the new user credentials by providing the username and password. Click Sign In. Remove the user that was creating problems in loading the examples. Click Administration, then click Manage Users, and check the user which you want to remove. Click on Hue on the top left corner, which will take you to the configurations. Click Examples tab and download these examples. If you click Data Browsers and then click on Metastore Tables, the existing databases can be seen, and you can also see some examples. Now, click on Hue. Click Examples and download the sample data. You can perform the same actions with the rest of the editors to download the examples. After downloading the examples, click Query Editors, and then click Job Designer, which will show some sample examples. Similarly, you can click Workflows and then click Editor. Under Editor, click Workflows, and you can see some sample workflows which we can use to submit and see how Hue can be used to submit jobs. Click File Browser, and you can see different directories in HDFS. Now, you can start working on HDFS to create files, change permissions. In the next demo, you will see further use of Hue and different editors. So, in this demo, you have learned how to add Hue as a service and setting up Hue. Working with Hue, Part 1. In this demo, you will learn how to work with Hue service in the cluster. Within the cluster, you can see that Hue is already added as a service. Now click Hue and click Hue Web UI to start using the Hue web interface. Click Configuration, and it will show the different settings being used. By default, if you have enabled high availability in the cluster, that role can be added to the Hue service. Now click Cluster and choose Cluster 1. From the Hue service, you can choose the service and click Add Role Instances to Hue. You will be able to see the different instances that can be added. Now, as you have enabled high availability and set up Hue, you might be prompted to set up Role Instance HTTPFS. After selecting HTTPFS, you can choose the machine to deploy Hue service. After choosing the machine, click Back. Click Hue Service. If you need to make any changes in the configurations, click Configuration, and Hue will show you the different services it contacts. To search for a particular property, type the property name in the search bar. After the search, it will show the particular property and its details. There are different categories in which you can look for information related to a particular service. For example, you can look at the configuration properties that are related to the Hue server or service-wide settings in configurations. So, in this demo, you have learned how to work with Hue service in the cluster. Working with Hue, Part 2. In this demo, you will learn how to use Hue as a web interface to work with the cluster. To look at configurations pertaining to Hue, you must enter the command /etc/hue/conf in the terminal. You can also look for Hue service in the OPT directory. The /etc/hue/conf/hue.ini command will show you different settings that allow Hue to connect to the cluster. The HDFS section shows where the cluster is running, so you can always make changes if required. Now, as Hugh is already interacting, you can see the properties for HDFS cluster. Also, you can see the Hube HDFS properties. So, whether you are configuring Hue to work with Apache, Hadoop, or Hortonworks, you can make the changes here by uncommenting the properties like fs_default fs or Hube HDFS. For Yarn, you can point to where the resource manager is running, what the port resource manager listens to, and so on. You can change all these properties by replacing the local host with your host name. You are now looking at the high availability related settings, HDFS and Yarn. Also, you can look for settings related to MapReduce and Beeswax. Beeswax is an application that allows users to work with Hive. Under Beeswax, you can find out where your other interfaces, such as Hive Server 2, would run and the default settings for Hive. For different services set up on your cluster, you can always find the details in the terminal. So, in this demo, you have learned how to use Hue as a web interface to work with the cluster. Working with Hue Part 3. This demo is the third and final part on how to work with Hue. You will learn the different aspects of working with the Hue interface. Go to your cluster. Click Hue Web UI. This opens up the Hue web interface and allows you to log in as an HDFS user or super user. At any point in time, you can click the Hue logo, which will take you back to the Check Configuration tab of the wizard. Note that you can view the other tabs, such as Examples, Users as well. You can click on the Configuration tab in the main menu to view all the applications that are already set up and their read-only properties. For example, clicking on Beeswax, you can see where your Hive is located. If the application requires any changes, you will see them listed as recommendations. It also lists the different properties that allow you to work with Hive, their descriptions, and the values that are specific to Hive. Similarly, if you click File Browser, you can view a few options. On clicking Hadoop, you can view the configuration section and variables, which indicate whether you have enabled security, where your name nodes are located, and what your web HDFS is, and other such properties. Note that this page does not allow you to change or edit the properties. You can only view the properties for each of the listed applications. If you want to view any of the applications, for example, Job Browser, click the application name listed at the bottom of the screen. Click the Home icon to go to My Documents. You can see some of the examples listed here. To add a new document, click the New Document icon. If you want to work on Hive, click Query Editors. In the drop-down list that appears, click Hive, which is added to your cluster as a service. This will open up the Hive editor. As you can see, some sample tables are already listed here. You can go ahead and work on them if you wish. On clicking any of the tables, a sublist is revealed, which displays the columns of the table. To view the graphical representation of the table, click the chart icon next to it. You can also create your own table by adding the relevant code in the query text field. Note that here, the query is in the default database. In the query, type Create Database Test AJ. Add a semicolon in the end. click the play icon to execute the code. You can see that the database is created. When you click Saved Queries, it shows only some sample queries that already exist in the database. However, you can see that your test.aj database is visible on the left panel. Click it to go within the database. To create a database within this database, type Create Table test.ajtb. To add columns, type ID integer name string within parentheses and end the code text with a semicolon. Click the play icon to execute the code. You will learn more about Hive later. This demo focuses mainly on how to use Hue. You can see in the query history that your table is created. You can also view the table within the test.aj database. Currently, the table with 2 columns is empty. To load data into the table, you can use the Load statements. Click the Settings icon. Click the plus icon under Files. If you want to relate or link your table to any specific file which follows the same column format as your table, you can also select specific functions or settings for your table. The Hive editor enables you to perform all of these actions. Optionally, you can also perform the same functions through your cluster. First, use the -ls command to list out the user directory. Here, you can view the subdirectories of all the user services already set up. You can see that there is a Hive directory owned by the Hive user. If you want to work on Hive as an admin, first log out and log in as an admin. Cloudera usually creates this user account. However, in this case, the admin account does not exist. So, to create this account, log in as HDFS and type Hive. This brings up the Hive command line interface through which you can perform the same actions as you would through the Hue web interface. Type Show Databases. This lists out all the databases that you have. Then, type Use test.aj. This takes you to the test.aj database. To view the tables in the database, type Show Tables. You can now continue to work on Hive either through the terminal or the web interface. The advantage of the web interface is that it is very user-friendly and can easily visualize the information. To work on Hive, you can also go to Data Browsers and click Metastore Tables from the drop-down list. As you can see, it shows you the default database within a list of databases in the breadcrumb trail. You can view some sample entries in the default database. If you don't want to use queries to create a table, click the icon shown here to create a new table from a file. This brings up an interface where you can fill in the table name and description and provide an input file. By default, it lists files in HDFS database. You can browse to your local folders and files and upload any file of your choice. Check the box to import the data from the specified file. However, if you want an empty table, then leave the box unchecked. Click Next. You can now preview the table where the columns and the values in them are listed. By default, the delimiter is space. To change the column names, click Next and go to the next step. For the error message, the selected delimiter is creating an uneven number of columns. Please make sure you don't have any empty columns. Let's go back and fix the issue. You can choose tab, comma, space, and other as the delimiters. Let's select tab.
Click Next. In the next step, you can provide the column names, type, and view what the data would be. You can also bulk edit your column names. Once you have made all the required edits, click Create Table. So the Hue interface allows you to work on the database without using the command terminal. Next, let's run a Hive query with different types of predicates. This triggers a MapReduce job, which allows you to verify if your jobs are running. Note that the table just created is listed here. You can query this table anytime using CLI or Query Editor. Let's now see how to use dbQuery. A dbQuery allows users to connect to RDBMS and extract data from external databases linked to Hue. From the Hue interface, you can also use the pig editor to create pig scripts. These scripts can be used to transform data used by Hive, HBase, or any other services. Job Designer refers to one more interface within Hue, which is used to create, edit, and submit jobs to the cluster. Under Data Browsers, you will be able to access Scoop Transfer only if you have set up your Scoop service. You can use Scoop to connect to an RDBMS to either import or export structured and unstructured data. To enable this functionality, you will need to provide drivers and other details, which you will learn later in the course. You can also look at Metastore tables. Here, it displays only Hive-related tables, but if you set up the HBase service, then you can also use Hue to work on HBase. Under Workflows, scroll down to Editors in the drop-down list to view the Workflows option, which allows you to create workflows. Workflows is a series of jobs set up to be run sequentially or on a specified schedule. To work with HDFS, click File Browser. This opens up an additional page where you can click Upload a tar or zip file, and that would be unzipped automatically. You can also create new files or directories. You can work with these files and change permissions for or delete data from them. Next, let's look at a job browser. As you have seen earlier, you can use this option to browse through jobs. The Resource Manager's web interface also allows you to browse jobs. Under Administration, scroll down to Manage Users to create users. Recall that we had created a user called HDFS. Note that the Hue user is created by default. You can assign users to different groups and assign specific permissions to each user. Click Add Group to create a new group. Click the question icon to view help topics. Click the arrow icon to sign out of Hue.
So, in this demo, you have learned
The different aspects of working with the Hue interface.